In mathematics, inequality is just an algebraic equation that is either greater than, less than, or equal to any other expression or constant. Let's start with understanding it. Let's say that we have an equation x plus 2 greater than 0 and we have to give its interval where it's true. Then you can generally say that x should be greater than minus 2. Let's understand the same thing in graphical method. We draw a line y equal to x plus 2. Now we can see that for x greater than minus 2, y is greater than 0, therefore satisfying the condition. Now let's jump into the quadratic inequality. Let's say that we have an equation x square plus 4x plus 3 greater than 0. So in the graphical form, we can say that y is greater than 0 only for x greater than minus 1 and x less than minus 3. Therefore, the interval lies between minus infinity to minus 3 union minus 1 to infinity. To make it easier, we'll assume it as any wavy curve having solution on any particular line. In our case, y equal to 0. We will generally take y equal to 0 because it will be easier to find the roots of the equation. Also, we would represent the points as closed dot if they are also included in the interval, else represent as open dot. Now we know that it is increasing from x greater than minus 1, so make the region positive. Similarly negative for the region between x minus 1 to x minus 3 and positive for x less than minus 3. So we can write the interval even from the wavy curve method, that is x equal to minus infinity to minus 3 union minus 1 to infinity. To completely understand it, let's see the different type of polynomial graphs. Let's first fix the coefficient of x equal to positive 1, so it will be easy in calculation. If we see the graph of any even power of x, it is increasing both sides of the point on y equal to 0. This confirms that for an even power, the sign of the wavy curve won't change. Now, for all the odd powers of x, it decreases on one side and increases on the other side of the point on y equal to 0. This confirms that for an odd power, the sign changes on the wavy curve. One last and important observation is that by maintaining the value of the coefficient of x equal to positive, the graph is always increasing on the right hand side of the wavy curve. Since now we know about wavy curve method, let's try to solve any polynomial. Let's say a polynomial with numerator of order 7 and denominator of order 5. So the first step is to find the maximum possible roots. Now when we found all the possible roots, the second step is draw the wavy curve and assign sign based on the power of the roots. That is, for every even power, the sign won't change on both sides of the point, and for every odd power, there will be a change in the sign. And that's one important point, that the right hand side will start with the positive sign. Finally, write the interval based on the open and closed dots. Congrats! Now you know how to solve an polynomial inequality. Another important inequality which is widely used is that for any given number, the arithmetic mean is greater than the geometric mean, which is greater than the harmonic mean. That is, for any two numbers a and b, a plus b by 2 is greater than root of ab, which is greater than 2ab by a plus b. Mathematical analysis relies on many such inequality in the proof of its most important theorems. Some of the application of inequalities include the Heisenberg's uncertainty principle, self-predicting deep learning models, and many more, both in physics, chemistry, and in real-life applications. Apart from this, there are many other inequalities such as the Agmon's inequality, Bessel's inequality, Bernoulli's inequality, Hardy's inequality, Hilbert's inequality, and many more.